All right, so here we go with binomial distributions, and binomial is a word with two parts. Nomial means number, and bi means two. So it is actually a random variable, so we're a little bit still talking about those things, but this is a special kind. It's a kind where, you know, outcomes either are, well, they happened or they didn't. Yes or no, success or failure. So you either made it to school on time or you didn't. You either passed the test or you didn't. You either ate dinner or you didn't, whatever. So if you get difficult problems and you think, wow, there's too many, you know, probability problems, and you think there's just too many things I have to keep track of, if you can just stop and breathe and then think, yeah, this is kind of, well, had a boy or didn't, or found a patient with HIV or didn't, then the whole thing becomes much, much easier. So here we go. There are 4 rules of a binomial setting, and you need to commit these to memory. So the first one is that each observation is falling into one of 2 categories: success or failure. That's the yes-no thing I was just talking about. But keep in mind, a success may not be the same kind of success that you might think of as being something positive. It just answers the question, did you find what you were looking for? So if I'm looking for people with HIV and I find one, that's a success. Not because that's a good thing for them, but because that's what I was looking for and it came to pass. So success or failure is the first one. A fixed number n of observations or trials. So if I'm going to test 1,000 patients and see if I can get 6 or more people who have HIV, then there's your fixed number of observations. That's 1,000. It's not open-ended. The n observations must all be independent. So if I find a patient who's got HIV, that doesn't mean the next one I check won't or will. We don't know. So all of those observations must be independent. And the probability of success is the same for every observation. So picture this. It's 5 kids. You're interested in 2 girls. Well, I mean, every kid that's born has a 0.5 probability of being born if it's according to gender. So, and it's the same for every kid. So we would have either it's a girl or it's not. There's 5 observations. They're all independent, and the probability of having a girl is fixed at 0.5. All right, since it's a random variable and since we're dealing with a discrete random variable, it follows all the rules for discrete random variables, including how to calculate the mean. However, the mean can be calculated with this simple formula, mu equals n times p. So if I flip 4 coins, I would expect to get 2 heads, right? So n is 4, p is 0.5, 4 times 0.5 is 2. So there it is in action. All right, so this is going to be a little bit tedious. If you feel like copying is important, then you can pause while you do it. But this is basically the notation and the formality of it. So the definition, a distribution of the count of x successes in the binomial setting is the binomial distribution with parameters n and p. Now, if you remember, normal distributions have parameters mu and sigma. So these are going to have a notation not too dissimilar from how you would notate normal. All right, n is the set number of observations. P is the probability of success. Possible values of x are 0, 1, 2, 3, up to n. So for example, if it's 5 children and I'm interested in 2 girls out of 5, then x in that case would be 5. So these you can see are whole number values. And to abbreviate this, we can say x is capital B for binomial with parameters n and p. When we're doing random variables that were continuous and normal, we said x was approximately normal, capital N, with parameters mu and sigma. So that's how AP people like us to do normal. This is how AP people like us to notate in the shorthand a binomial situation. And this is a complete description. Okay, I mentioned binomial variables are also discrete random variables. And here is how you would formally write this out. So x is the number of, let's just say, girls out of 6 births. Number of girls out of 6 births. Okay, so there it is in context. When you just answer number questions for me, you know, you can write out the calculator speak, but if you're going to do this on AP exams or if you're asked to do it on a test or a quiz, this is how you do it. So AP requires you name the distribution. X is the number of girls out of born out of 6 kids. Identify the parameters. N is 6, P is 0.5, it's binomial. And then you provide the correct calculation. Okay, so there are 2 ways that we're going to go about calculating these things. So the first one is going to be a binomial PDF. Binomial PDF, probability distribution function. Don't leave the binomial off of this and just write PDF, because there's a lot of PDFs for other things, okay? So given a discrete random variable x, the binomial PDF assigns a probability to each value of x, all right? So it answers the question, you know, which asks for exact values. Exactly 2 out of 6 kids are girls. Exactly 4 coins out of 20 that I flip up in the air are going to be tails. Okay, exact. No less thans, no greater than, no at least, no at more, no more than, no less than, where you're indicating with all of those examples a range of values. This would just be one single value. And this is what it looks kind of like on your calculator. So example, if a family wants to have 5 children, what's the probability that they'll have exactly 2 girls? Now, when you get a problem like this, if you don't recognize that it's binomial, which it most surely is, because you either get a girl or you don't, right? That's yes, no, success or failure. Basically, if you think about it, if you hold up 5 fingers, well, the first 2 could represent girls. The last 2 could represent girls. The first and the third, the second and the fourth, the third and the fifth, the first and the fifth. Okay, there's all these different combinations of ways that 2 girls could appear out of 5. I think there's 10. So if you're going to try to do this or this or this or this or this with regular probability 10 times, you're going to go crazy, all right? So, but if you recognize that it's binomial off the bat, then it's one simple calculator calculation. So x is the number of girls out of 5 children. It's binomial. N is 5. Probability is 0.5. And that's what it looks like. All right. So I'm going to get out of here and we're going to pull up the calculator. There's the calculator. All right. For me, I'm not going to go to a page because this is just crunching numbers and pages sometimes get tedious. So we're going to go to a scratch pad. And if you remember where normal CDF is, it's under Menu, Probability, Distributions, and there's normal CDF right there. Binomial PDF, since it's exactly 2 out of 5, is right there. If you don't see it right away, then just scroll down and you'll find it. It's in here somewhere. All right, so this is Binomial PDF. You need that. And you'll need CDF for later on. But right now it's PDF. Right, number of trials was 5. Probability of success was 0.5. And the value for x was 2. Hit OK. There it is. Now the neat thing about this is, and you can compare it to what was here, right? We got it right. See it? Okay, so so back to this. If you have this up here, you can actually go up, up, highlight it, hit enter, and then just say, well, what if I want to know about 4 out of 5? Change the 2 to a 4, hit enter. or none out of 5. You could do that, all right? Go up here, get into the parentheses, delete the 4, put a 0. So it's really quick. You don't have to go through all those drop-down menus. It's very good if you need to do a bunch of PDFs in a row, right? Okay, so back to this. Blink, blink, bump, 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 bump. Okay, we found this answer. Okay, now, but what if I want at most 2 girls out of 5 births, all right? That's not just one value. It's either 0 girls or 1 girl or 2 girls, okay? At most two girls out of 5. Okay, you can do 3 PDFs and add them up because it's or in between, but that can get pretty tedious too. So we're going to go into Binomial Cdf, which is cumulative distribution function. And what that does is it calculates, the Binomial Cdf of x calculates the sum of the probabilities for 0, 1, 2, 3, up to whatever value of x you want. In other words, it calculates the probability of at most x. Well, that's what the formal definition is, and this is what comes up in your calculator. N is first, probability is second, then 0 to whatever x value you want. But in your NSpire calculator, you can change that 0 to whatever number. So you can do from 2 to 5. You can do from 1 to 4. Whatever you want. All right, so it's really, really handy and much better than the TI-84s from years ago, because those things only went from 0 up to a number. And if you wanted to go from a number up to n, you had to play some games to make it work. Not now. So if a family wants to have 5 children, what's the probability that it will have at most 2 girls? That's at most 2 girls, and that's a binomial CDF. 5 girls, 0.5 probability, check that, 5 kids, 0.5 probability of a girl, starting with 0 and going up to 2. It'll add up 0 or 1 or 2, and you get that. So let's play around with that. Okay, so we'll get this up here. And you're going to have to go into the menus, because you can't make a PDF become a CDF. So menu, probability, distributions, and you're going to have to scroll down. This did this to me all day long. Okay, you would have thought I would have known better. All right, we'll try this. All right, so I'm just going to scroll up. All right, where did it go? Come back. All right, there's Binomial CDF right there. All right, so I'm going to pick it. All right, so this is going to be 5 trials. Probability is 0.5. The lower bound is 0, and the upper bound is 2. Hit OK. And there it is. Now, once this is up there, you can do all manner of things. So what if I want at least 2? All right, that'll take you from 2 or 3 or 4 or 5. So we can just go ahead and change those first 2 numbers. This will take the 0 out and put a 2. Then we'll take the 2 out and put a 5. And now you've got at least 2. All right? And you can do whatever you want. And the neat thing is, if you want to know like a binomial PDF for just 3, you can do it on a CDF. So you can change it from 3 up to, wait for it, 3, right? And that's going to be whatever. Remember that number from before? All right, so you can do a CDF for anything, but a lot of people like switching back and forth. So, okay, let's see what we've got after this. All right, we have some examples. So they're going to change this one up. You're going to have 7 children. And so we're still looking for a number of girls out of 7. So this is binomial with n is 7, probability is 0.5. And that would be at most 4 girls. All right, so I guess I'll just leave this where it is. So at most 4 girls. All right, I'm just going to go ahead and grab this. I'm going to make some changes. All right, so let's see. First of all, that has to go to 7 because it changed from 5 to 7, and it's at most 4. So that means from 0 to 4. And there it is, 0.7734. The next one I think was at most 4. Ooh, I did the at least first. All right, I'll do the at most now. My bad. I have to switch back and forth. So the at most, let me see what I'm doing here. All right, at most 4. Ooh, I just did at most. Okay, I'm good. So at least 4, we'll just go ahead and copy this. And so that's going to be 4 to 7. So delete the 0 and put in a 4. And then delete the other 4 and put in a 7. So that'll be at least 4. Okay, what's next? Between 2 and 5 girls inclusive. Okay, that's simple. Just go ahead and grab this, and we'll change that 4 to a 2. And we'll change this to a 5. Okay, there's the output for that. And I just want to bring something to your attention here. What if we just took that word inclusive and just took it right out of there? And it was just between 2 and 5 girls. Wouldn't that be the probability of 3 or 4? Because if it doesn't include 5 or 2, but it's between them, you need the 2 that are included, and you have to leave out the 2 that aren't included. See that? All right, so more than 4 girls, less than 4 girls. Here we go. All right, so more than 4 girls would be 5 or more, right? So that would, let's see, that would have to change to 5. You don't want to include the 4 because it's more than that. And the most we can get is 7. So there it is, 0.2266. And then, what was the other one? Less than 4? All right, so that would put you, the lowest value would be 0. And the highest value, if it's less than 4, would be 3. Okay, there it is. I don't know what more to teach you. I think this is it. All right, the homework is page 1 and 2. And my key is online. It's more geared toward the old style calculator, and I'm just putting it up there for their benefit. But so just get the right answers and just write out what the calculator is, like Binomial Pdf or Binomial Cdf, and then the values you put in. All right, just include that much, not just the answer. And that'll be due Wednesday. So on that note, I'm going to ship this up to good old Google or YouTube, and I will bid you a fond good night.